the challenge 0 we do. And for the first one, the level 1, I cannot change the slide. Oh, okay, okay. For the level 1, we load the file and compute and check if the data is going wrong or not, and visualize it. And this is the code we import the file, and we check the data have some weird data or not, and it seems the data is very correct because the result shows that. Okay, next page. And later we compute the summary, and this is the graph we draw by using the library. Okay.
Let's stay there a second. Go back. So you have the mean, the median. Go back. Yeah. So this is the ratings. Okay.
Yes, this is rating.
Good.
Okay. We also count the number of movies per genre. We saw that the drama has the most number of the movie. It means most of the movies in this data set is drama. And this is the graph. This is a visualization of this result. And this is the distribution by average rating. This gives the information that every user rate about 3 to 4 rate the view of the movie. Okay, and we go into the visualize part. This is the first question. Is the histogram of rating, like we showed early. This is the result. And this is the second question. And yes, drama. This can also tell us the drama is the most composition in the data set. And this is that question, the backplot. And I didn't use the backplot before, so this is the first time I try to draw a backplot.
Do you understand what it means though?
The orange line is the average, and the bottom line is the quarter, and this is also a quarter. Oh, it's this one. Okay.
Then you have the outliers, right? Then the dots are the outliers.
Oh yeah. Okay. After we analyze the basic data, we need to utilize this data to get some trend or the more useful information. So this is the level 2. The first one we can know the change of the number of rating per year. Like we can see the number of ratings have a big change every year. Okay, next one. And this is the average movie rating per year. We can see between the 1979 to 2005, the average movie rating is going down, and after this year is going up. Are newer movies rate differently? The trend. This is also show the change between this year. Okay.
Do you have a hypothesis why the movie rating dropped?
This one?
In the middle, yeah? Between the 2003 2006, why is the movie rating dropping? Do you have a hypothesis?
maybe it's let me think about it. Maybe the network is grows very fast, and they use the oh, it's a DVD or something like that. Yeah, am I right?
I don't know. I'm asking you.
Oh.
So, your opinion. This is not.
I guess it's the DVD rental or something.
Good.
Okay.
Go ahead.
Okay, the text usage. How often are texts applied per movie? And we can see the sci-fi has a more text, and the last one is the dystopia. It is it's a very not famous text.
It's interesting, right? Most of the movies are drama. Sci-fi is the least popular category, but then sci-fi is the most used tag, right?
Yes. Okay, the next one will be is the relationship between number of this one told us the numbers of tag and the numbers of rating has a strong relationship because the in the correlation is 0.69. It's quite high. Okay, the genre and rating interactions. For each genre, compute average rating, numbers of ratings, and variance, which genre shows most agreement and disagreement. Because this part is not for me. The teammate is still not here, so maybe I will try to
No worries. Go ahead.
Horror shows the most disagreement since it has the highest variance in rating.
So you understand the table, right? So here you have the mean, the count, and the variance, right?
Yes.
So the film noir. Do you know what is film noir? Do you know film noir?
No, I didn't know. I can search right now.
Yeah. So film noir are very artsy movie, right? So they are movies with like French direction from the second, from after the Second World War, let's say.
Oh.
So the traditional cinema is a very authorial type of cinema. So they have, but nobody watches this movie, right? So nobody watches this movie unless you are a movie buff. So the story here is that the people that like movies, they do think that these movies are the best ones, and they all agree on this. So they go and they rank them very highly. Okay. And this is in contrast with horror movies, right? Where there is a lot of subculture. It's almost a subculture, right?
Yeah.
So horror movies don't appeal to the general population, right? If you see somebody getting cut in half by a chainsaw, you cannot bring your baby to watch this, right? It's not a family movie, right?
Yeah.
And so the idea is that they have the lowest rankings, right? And also the highest variance, because it reflects the fact that there is a sub community that really likes them and give them a high score, but then a bunch of other people do not like them and give them a very low score, and this results in a high variance.
Oh,
correct?
Yeah. Okay. I know. So like the people who like this is very like, and the people who don't like is very hate this movie.
Very polarized.
Like,
in fact, the count of ratings, right, of the film noir is very small because only a small population of people watches these movies. So the general population just doesn't watch them. But the horror movies, they are still have a larger appeal. But among this larger appeal, they're very polarized.
Oh, okay. Okay. And I will go into the next page. Thank you. The advanced question. This is the part for our leader because I didn't finish this part.
Let's see. Let's hear it from our leader. What is our leader? Yeah. Come. Where is our leader? Hello. Where is our leader?
Our teacher, he said the part after level 3 is still not complete. So the presentation of group A maybe will end here. Sorry.
Really? No. Okay, one teammate missing.
Yeah.
Incomplete. Patrick did a good job.
Thank you.
That's my comment. So did you choose? So since the leader is here, did you choose a name for the team, or just to call you Team ABC?
Yeah, we decided the team name called A+.
A plus.
Yes.
You guys are terrible. But what am I gonna say? I think you pick up the humor from me, you know. Okay, very good. Let's see if we can have the next team. What's the name of the next team? Let me check my paper. Team Tank. If you guys come ahead, Team Tank. Come talk to me.
Hello, can you hear me? Oh, shit.
With a lot of echo. Let's see if you can figure out it.
What about now?
Should be good.
Okay, Jason, can you screen share the slides?
I can hear the leader leading around. Huh? Very good. I appreciate it. Team Tank.
Hello, Jason, are you here? Okay.
Whenever you're ready. Yeah, so there was 3 people eventually, 3 people of you that were active. Okay, good. Because so some people didn't show up, right? But 1 person showed up eventually from last week. Yeah, correct?
Yeah.
Okay, good. Go ahead.
Okay, so Jason, are you here?
My turn now. Okay. So this is basically what we did in this challenge. So we uses the data set movie lens 20M. Also, this is not for this next page. Oh, so this is the overview of the data we use. This is like wait. This is like the what? Wait.
So here it shows the data type and how many data's in it, and it shows the information about the data.
And some missing values or some weird values. Okay. So next page. Oh, so here we have the ratings distribution. So we have these statistics in the left and the graphs in the right. So as shown in the chart, we can see that from 0.5 to 5, 27% of the viewers rated 4, and 27% of the viewers rated 3. I think the ratings are like this is because most people they just watch movies as leisure activity, so ratings are not very important to them. So they just rate 3 or 4 as the middle score if they don't think the movie is good or really bad, or they just don't rate. Okay, next page. And this is just some movie genres. This is by the count of the movies. So just like comedy, and the drama, they are just really common. So they're just a lot of them listed in this genre, and others just not that much. So yeah. So next page. And so here we investigate the user behavior. This part, we analyze this by how many ratings does the user do and how high their ratings are. From the statistics in the chart, we find out that a large percentage of users didn't just don't do a lot of ratings. They just watch movies and yes. And this can be found as the chart earlier. So they don't consider rating movies just that important, so they don't rate really often. And the second chart shows the average ratings of a user, just mainly between 3 and 4. So yeah, next page. And this part, we investigate the ratings done by top 5 movie genres by movie count and using the box plot. So the orange line is the median, so they all fall between 3.5 to 4. And the green triangle also is the mean. It's close to the median, suggesting that the distribution is quite symmetric. Except for romance, it's just yeah.
Let me
box
let
ring,
me put it there.
like-
So, can you repeat the statement? Let's see if you can elaborate it. Right. So you said that if the median is close to a mean, this means that the distribution is
what?
Let's elaborate your statement. You said that when the median is close to the mean, this means that
The distribution is relatively symmetric.
Mhm.
Yeah. Okay.
is that
And so
we have some comments on this. Is it good? Is it bad? The distribution is symmetric. What? Yeah. So why is it good that it's symmetric?
I think if the median is higher than the mean, and this means that more users rated higher on this genre. So if they're really close, it's just average rating, just not really much people like this or dislike this, I think.
So remember the romance, we discussed it in class because we said that romance has a very different rating between male and female, right? And so this is what, for example, this is what will cause a very asymmetric distribution, right? You can imagine that. Again, guys, don't get me in trouble with the terms, right? So let's say that we have people that are male and people that are female. Let's discuss further this, okay? So let's say the males, they have a certain percentage of the population that goes and votes with a low grade, with a certain grade, and then female go and they vote with a certain average scoring. But then the other truth is that among the users of the website, I suspect that the males are much larger than the females, right? I don't suspect that if you look at the statistics of participation to this scoring, my intuition is that it's not really 50% male, 50% female. So you will see distribution for the male multiplied by the number of male people that vote, and a female by number of female vote that they use, and this will cause an asymmetric distribution. And so, as you were saying, there will be a bias toward a difference between the mean and the median. Yeah? So I just want to make this point, right? That even if the distribution is multimodal, so let's say that you don't have a peak and distribution, you have 2 peaks, you could still have that the mean is equal to the median because the distribution will still be symmetric, as you said. Okay, go ahead. It's good.
Okay. So next we oh okay, okay. So the next part is about temporal trends. In this chart, we just listed the ratings of all movies per year, and the years go on like this. So as we can see, there are three obvious peaks from the line chart. I think the first one is about 1996, and the second is 2000, and uh, the third is 2005. So these 3 years or about that range have a lot more ratings compared to others. I think there are some possible reasons to this. So first, it may be there are some really popular movies that come out these years, like the famous Mission Impossible just came out like 1996. So of course, the popular movies will have much more people watched it, and so will increase the numbers of ratings of the movies. And second, I think it's also maybe because the movie count of each year is just different. So this may be one issue to affect this phenomenon.
Mhm.
Okay, so next. And this is more about the temporal trends. So the first one is the line chart of average ratings per year. So as we can see, the average ratings over like 2 decades are just about the same, like in 3.5 to 4. And I don't think there is some, and and the second one is the movie average ratings by release year. So they're just about the same. So I don't think there are clear preferences in old or new movies. But the third, the bar chart of the numbers of ratings by movie release year. So obviously it is the old movies has clearly more ratings compared to the new ones, since the old movies came out just longer. So I think there's just more people that watched it. So the movie rating number of ratings is just more. Okay, next one. So there we have the tax usage. The first graph is about the tax per movie. So as the graph show, there's most movies just don't have a lot of text. So some movies just have one or some really few text, while a small amount of movies has more than 1,000 or nearly 2,000 text.
Yes.
And the second graph shows that uh, the frequently used text, such as sci-fi or based on the book or something. So these texts used more frequently, I think, just because they're just more popular, more popular types of movies or something. Okay, next one. Okay, here we have the text usage of the relationship between numbers of text and movie popularity. So the graph shows the higher rated movies. So higher rated movies, so which can be viewed as popular movies, will be assigned more text because many people watch them, and so there's just more people to assign them text than the unpopular ones. As we can see, the correlation here is 0.9696. But this trend shows strong long tail effects. Most movies have very few ratings and text, while a small amount of popular movies accumulate many text. Okay, next one. Next one. Okay, so here we have the genre and rating interactions. Statistics here shows the rating information of each genre. So here we rank them by the numbers of ratings. So as we can see, drama and comedy are the most popular ones with the highest number of ratings. Okay, next one. Graph here shows the average rating for each genre. So the film noir has the highest, showing that this genre is relatively liked by its viewers. So yeah, and the next graph shows the variance of ratings. So the variance of ratings can represent the controversy of each genre. So higher the variance, the stronger the disagreement of how people like it or dislike it. So here the horror ranks the highest, while drama and war are the lowest. Okay, next one. Here we have some statistics about the mean rating of single and multi-genre movies. So their means are really, really close. But the numbers of rating is quite different. The single genre movies have 3 million ratings and multi-genre movies have 16 million. And the variance also shows that ratings for single genre movie are slightly more spread out, suggesting greater disagreement among viewers. I think this is because single genre movies may be something like documentary or some not that popular types of movies. So, and the popular movies, the blockbusters are usually multi-genre. So I think this is just why.
I see.
Okay, thanks.
Okay, here is my part. So we will talk about decades difference. We took 1995 to 2005 and 2005 to 2015 year. So here on statistics, you can see that top genres on first decade are drama, and on second decade it's crime. And here it's easier to show average rating. Like we can see average rating, it didn't change, but number of ratings changed a lot, as we also saw before on my teammates plot.
Cool.
Then we can see top genres in different decades. So, both of decades have the most popular drama, but the interesting thing is comedy and action changed places. And same thing happened to sci-fi and romance, for example. So next, rating variance and gender diversity correlation. So here we can see the correlation between rating variance and gender diversity, which means that sorry, I'm nervous. And we can see number of ratings and the
Let me try to help you, right? So here you have different user IDs, right?
yes,
And you have that you have a sample, a certain number of users, and you can see the general diversity is how many different types of movie they watch,
right.
and variance of the rating is there. So let's look at the plot, right? So the rating variance is on the y-axis. On the x-axis, you have the general diversity.
Yeah, so here we are talking about users' profiles, and
Nice.
that's like we can see this red line, trend line, and it's pretty
Let me help you. So the trend here is just like the horizontal line, so
Yeah,
which
horizontal.
shows that although the user have watched more genre diversity movies, they still give like the same controversy ratings. So it doesn't depend on how many types of movies a user have watched. They still give a very justified scores or ratings on each movies.
But let me just think, because here you don't look at the number of ratings, right?
And we
Yeah.
look at number of ratings here,
Yeah,
but
yeah, but like in the
don't-
plot, you don't
we
see
don't
that.
show it in the plot. Yeah.
I was just thinking, like, yeah, of course, because for example, there you have one guy that gives 700, and then the next guy that giving twice as many ratings, and they have a very similar general diversity, but means that one saw twice as many movies as the other. So I was just thinking,
Yeah, I didn't consider that part. I didn't scale to each ratings per
No, of
users.
course.
I just use the
It's very high
value.
dimensional, right? We were just thinking, yeah. Go ahead. Very good.
Okay, so next we are talking about tech genome. We selected the movie The Matrix from 1999, and here we see that top genome tags for Matrix are dystopic future, cyberpunk, two ways of writing sci-fi, and the top user text for Matrix is sci-fi. So, and next one is virtual reality, but it's much less popular, like much less than here. So I think it's correlates with what my teammate one more time talked about before, that sci-fi is really popular tech among users. Yeah. Next, also we see correlation between tag genome and user between genome and user tags, match ratio, and it plot goes by year. And here we use only top 10 tags, and on this graph we use top 50 genome tags versus top 10 user tags. So we can see that it's there is no big difference actually. Only
我人这么多，先给你。
Sorry, your microphone is on. 后滑. Anyway, so here I want to show is
没关
that
系啊，我等一下。
I can mute him. Let me mute him.
okay.
Go ahead.
So here, what I want to show is I want to see if because they have built a AI or what kind of algorithm for computing a movie's genre. So here I want to show the user's tag is close to the genres or not, or they just give whatever text they want. And so here I compare the user tag and the genres, and it shows that half of the text or half of the genre is what the users gives the text, so it matches. And I think the number here is not that high, is because just like a sci-fi genre, a user might have a hyphen between it or not, and both of them can be a tag. So it not match in this case. So some part of the text might not perfectly match the genre, but it is still the same types of the movies.
Yeah, because there is no semantic understanding. Right? This is what we were discussing with the last time, right? That you could. Anyway, so we'll get there. I understand. Good.
yeah, here is smooth graph. Oh, yeah.
Nice. It's nice.
So here we can see top text relevance by genre, and it's interesting because we use three genres: action, horror, and romance. And
Okay.
for the most relevant tag for every genre is original. And if we go below original, we see that for action, for example, the most popular relevant tag is mentor, which maybe is connected with a lot of action movies about sport with Mentor.
Okay.
And yeah, so
Stay there. Stay on that slide a second. Yeah.
here we see same.
Can you go back? Can you go back one slide?
It's same plot but in each map.
Okay. Yeah, because can you go back one slide again before for me? Just, yeah. So here, then you're saying that then you have some tags which are specific to the more unequivocal, right? So the
Yes,
PG-13.
these tags are much more relevant for horror. These for romance.
So, but these are the tags that you plot for relevance, right? Good.
Yes.
So after the first let's say 10 tags, right? Then it becomes becomes like a one-to-one mapping, right? It becomes like a function, right? You can say that all the horror movies, the gory one only associates to the horror movies. Interesting. Because it means that these tags are really, only a small number of tags are really used across this region. Okay, very good. Go ahead, go to the next slide. I'm still trying to absorb it, right? So the heat map. Okay, got it. Action, horror, romance, drama, comedy, sci-fi, thriller, and relevance.
Yeah, so it's just another way showing of a previous graph, and it's much easier to observe.
The strong correlation between sci-fi and Mentor, great ending and dialogue is the one that are used by everybody. And then good soundtrack, it's also pretty spread out. And action-packed, of course, applies to romance. It doesn't apply. It only applies to action. Yeah, sci-fi. Okay, very good. Nice. John?
Yeah, so here I was thinking about some hypotheses, like about few rating movies, and can they be more popular if they would have more ratings? And so here we see that the
Wait a second. You're saying that basically I want to say if you could increase the rating of the movie.
yeah, but the thing is they have high tag relevance.
Okay, go ahead.
So yeah, they have high tag relevance, but still they have like too few ratings. So probably if they have more ratings, would it help them to be more popular? So what I thought when I saw statistics that these movies all are like pretty old. I would say very old as for movie, and it would not be interesting for people now. Also, if there will be any remake of the movie, it can like increase interest in the original.
I just wonder what is this headless body and a topless bar. I mean, it's the movie. We have to check it out, guys. Yeah. I understand your point. Yeah, go ahead.
Okay, so next are challenge questions. First one is which genre has the biggest average rating, and it was already discussed before. It's film noir and
noir.
Like noir. Film noir, and it has 3.96 average rating. And second question is, does it change if you only consider movies with at least 1,000 ratings? And no, it does not, except rating now is 4.0, highest rating. So question number 2 is which users are most active with most ratings and how their average rating compares to less active users. So here I took most active users and least active users. We can see their like here an amount of their ratings, so least active and most active, and here their average rating. So as we can see, most active users are like have more diversity, especially this one is like
Hates
very
everything.
interesting. 1.5, 1.6 is
It brings down the whole
average
website.
average rating. And least active users are much like more closer to each other, closer to average, I would say. So probably it's because it's just people that don't do ratings, and if they do ratings, they just put 3 or 4 because it's just usual movie for them. And third question is which tags are most frequently used. So here we can see that sci-fi is the most popular tag, and based on a book, atmospheric comedy, etc., etc. And second question of challenge question 3 is, are there tags that are used often but have low genome relevance, or vice versa? And yes, there are. So as you can see, first of all, it's original. It's very, very relevant, but still it's not really popular among users. And here you also can see sci-fi one more time. It's very popular, but very irrelevant. Yeah. And question number 5 is for multi-genre movies, is there a genre pair that tends to get higher average ratings than the individual genres alone? Yes, there are. In these statistics, you can see that like movie with pair, genre pair with biggest rating delta from average between just these genres is crime and IMAX. So, and second most like biggest difference is mystery and western. So their average in the pair is 4 and 3.99, and average just combined is 3.66 and 3.61. Also, pairs have it doesn't show it here, but pairs have much more ratings.
So this war and musical, how many movies can you put in the war and musical category? What's a war and musical? Sound of Music, Les Miserables, and that's it, right?
Probably old movie about war with some very intense music.
No, it means musical, so it means that the action stops for people to go singing. That's why I think the Sound of Music, right, must be inside there. You know the movie The Sound of Music?
Yeah, maybe it's movies from the war times that made people go to war. Yeah.
Very good.
Here
Go
is
ahead.
part of my teammate Jason.
Jason, you're here.
So next, I will introduce the stretch goals about that baseline predictor. So the purpose of this is to serve as a simple and interpretable baseline model for comparison with more advanced algorithms, and to validate the data processing pipelines like splits, features, constructions, and RMSE evaluation. So the first step, we sample the ratings from the ratings.csv for efficiency, and we split the data into 80% training, 10% validation, and 10% testing. Okay, so next page. And we construct our features. So we computed 4 types of averages as predictive features. So the first one, we have the global average. It's the overall mean rating across all users and movies. And we have the user average. It's the mean rating per user, capturing rating bias. The movie average is the mean rating per movie, reflecting general popularity. Genre average is the mean rating of the movie's first genre. So the next step is the model design. So the predictor is a weighted combination of the features as I put it in the Canva.
Mhm.
It's like that. And this integrates user habits, movie quality, genre preference, and global baseline. So yes, next page. And so the next step, uh, previously we just tested the predictor with some fixed weights. And here we performed by doing a grid search to look for the best combination of alpha, beta, and gamma. We choose the best combination by using the validation set RMSE. And finally, the best configuration was evaluated on the test set using RMSE. And the results, and we have the results in the observations. The baseline predictor is significantly outperformed the trivial global average baseline. And weight analysis shows the user averages and movie averages contributes the most, while the other two just provide minor adjustments. And the model is simple and interpretable, and serving a strong benchmark for advanced algorithms. Yes. So next page. So next we have the clustering. We applied 2 main approaches. This is the first one. We clustering by genres. So from the movie.csv, we extracted the genres field and converted each movie genres into a one feature vector. And then we apply k-means clustering, dividing movies into 8 clusters and on the genre similarity. So there is like a lot of dimensionality. So for visualization, we used PCA to reduce the dimensionality to 2D and plotted the clusters.
Yeah, so guys,
Oh,
PCA
there-
in the class, so don't worry. Just think of it as a low-dimensional projection or some high-dimensional. So we see it in the class. Go ahead.
Okay, so the results shows that the clusters correspond to major genres, such as one dominated by some action films and other by romantic comedies. Okay, next page. So the second one, we have clustering by genome scores. The genome scores CSV provided 1,128 tags relevance scores per movie, which are more fine-grained than the genres, which tags like time travel or dark humor and such. Next, we pivoted
Sorry,
the data.
how do you convert the tags into something that you can put into PCA? You do a binary, also that you do a binary mapping of the feature vector?
The PCA. Can you help? I'm not really sure.
And that would be
I mean my teammates.
Binary mapping.
you do a binary mapping?
Yeah.
Yeah, because you see that you lose all information, right? So you see that the binary mapping here is not giving you information because there is a closeness between tags, which is not reflected in the binary vector, right? So you know what I mean?
Yeah.
Yeah. Good. Go ahead. So this cluster, so we were going to discuss this later. But this clustering here, it's not good. So because basically the clustering is unsuccessful. So you are not really being successful here. So we're going to see later in the class. But basically here you just have a big uniform distribution of the data, and you cannot see any cluster like in the previous slide, which means that the way in which means to me, from my eyes, that the way in which you converted the tags into a feature vector didn't preserve the semantic information in the tags, and so the clustering was unsuccessful.
Okay.
Does it make sense?
So the next part are just like similar to the previous ones by movie genres. We also use k-means to cluster the movies and do the visualization by using two PCAs. Okay. Next part we have the user segmentation. In here, we not only apply k-means and also use PCA for analysis. So first, we construct user features. We characterize users by rating bias, rating variation, and how many ratings they do, and the average ratings across genres.
Good.
So next, we do the normalization and clustering.
Okay.
Features were standardized using the standard scalar. Then we apply k-means, like k equals to 5, and group users into 5 clusters. So then we use PCA to reduce the high dimensional feature into 2Ds for visualization. I think here PCA1 captures the largest source of variation and PCA2 captures the second source of variation here. So yeah, like that. Next.
Okay, so here is another stretch goal, which I will introduce the KN here first. So KNA is a non-parametric instance-based method, and that means it doesn't assume a fixed model form. Instead, it relies on comparing a query item directly with the data points around it. So it is often used in both classification and regression. And the steps are simple. So first we choose a distance metric, and here I give two examples like cosine distance and Euclidean distance, and the formula on it is clear that the cosine distance is 1 minus cosine similarity, and the Euclidean distance is the root of square of each feature's distance square.
So let me ask you. Here the features are again the tags. What do you use as features here? Can you tell me?
Oh yeah, I will talk about it later in the following slides.
Go ahead. Sorry.
Okay, so next we'll find the k points that are close to the query point. So finally, we use those neighbors to make predictions, either by the, just like the votings. So we choose the k number, and then nearby k members will classify the one we are looking for. So okay, next slide. So on this slide, I show a simple result of applying the KNN on movie lens dataset. So here I use features such as average rating, number of ratings, and release year, and text and genre information, these 5 features. And I scale this and weight in these features, and I compute similarity using cosine distance here.
Okay. Yeah.
And here I show the metric 1999 movies, for example, and which is highlighted in the red star here. And the blue ones are the most top 6 close movies to it. And you can see the distance here from the cosine distance. And it is important to note that this is not clustering. So we are not grouping all movies into predefined categories. So we perform in neighbor retrieval, we only define a local neighborhood around the query movie. So you mentioned the PCA, so I'll just talk about it simply
Okay. Okay.
here. It takes high dimension data, for example, here our movie with many features like ratings, genres, and text, and transform it into a smaller set of principal components. So these components capture the direction where the data varies the most. So by keeping only the top components, we can represent it on the low dimension, like 2D dimension, so we can see it clearly. And so in this case, PCA reduces the movie feature space into 2 dimensions. Okay, next slide.
No, wait. We have to comment here, right? Because I think it's nice, right? So, like you do. So, Truman Show, of course, it's very close, right? AI is close.
Yeah,
The Shining, Pulp Fiction, I have to think if they are close in some dimension, right? Because I think Pulp Fiction is close, maybe as maybe some dystopian or some action, or maybe the action aspect, right? Maybe the action aspect.
yeah.
Shooting. And The Shining is purely.
I
Why
don't
is
know
that?
some of the movies here, but I'm sure that if we got,
Which movie you don't know? Which movie you don't know?
I don't know the Zoolander.
Oh, that's a comedy movie, Ben Stiller from the 2000s. Like they're like top
Oh wait,
models.
I know it in Chinese. I just don't know it in English.
Okay, very good. Which
Yeah,
other movie you don't know?
I think the others I know the others.
If you don't know The Shining, I swear I'll be very angry with you. Okay.
Okay, yeah.
You don't pass the class. Yeah. You have to retake the class next step. Go ahead. Yeah.
Okay, next page. So after the previous one, I separated features into different groups. So I do then separate and make them combine. So in this first experiment, I only use numeric features like average ratings and number of ratings or releasing years. So on the left with cosine distance, we can see the matrix is closest to movies like Pulp Fiction and Truman Shows and AI artificial intelligence. And on the right side, we use Euclidean distance. So the neighbor shift slightly, now including films like Shawshank Redemption and Silence of the Lambs. And this shows that different distance metrics can change which movie are considered close. Okay, next page. So in the second experiment, I only use genre 1 hot vectors, so which means the similarity is purely based on shared genres. So here we see that all the nearest neighbors are science fiction, I think, and cyberpunk theme movies, like Johnny, how do I pronounce it? Mnemonic. And the cosine and
Right from Keanu Reeves movie.
oh
You
yeah,
know it's the book, right? Do you know the book?
yeah, I know the book and the movie.
You'll pass the course, I'm sure. Yeah.
Yeah, and the cosine and Euclidean version gives almost the same neighbors groups, but since it just use the feature of generate and in one half vector, so the distance are all zero, so it just separate all the movies into just like different groups of genres. So
Exactly.
this confirm that generate information along groups. The metric with other sci-fi movies is in one dot on the film. Okay, next page. So finally, I combined both numeric and genre features, and now the neighbors are more balanced. We still see sci-fi films like Blade Runner, but also critically acclaimed titles such as Shawshank Redemption and Fight Club. So this suggests that combining genres with popularity and rating statistics creates more meaningful clusters, and it captures not only the thematic similarity, but also the audience reception and cultural impact of the films. And what we can do with this nearby is that the platform can show the users what kind of movies they might like or they might also want to watch. I think this is one kind of usage. Yeah, that's it.
recommendation systems. Yeah, that's what you're talking about.
Next page.
Okay, so here is the last stretch goal about seasonality of releases and unsupervised temporal patterns. First, we extracted number of movies for each month of the year, and it's interesting that the most popular month is January. Probably it's New Year and everything. And next slide is about clustering movies in accordance with their release month and their average rating, number of ratings, and the genre itself. So the popularity of movie and its genre, and here, like before, already technology was explained. So here we just can see that first of all,
Drama.
3 dramas and 2 comedies are clustering, and that the most popular is on July. The June, July are the biggest average rating and the biggest number of ratings also, and comedy is most popular at that moment.
Okay, good. Okay.
Okay, so here on the left, the heat map shows the distribution of genres across different months. And for example, you can see certain genres having stronger peaks in specific months. And on the right, I focus on selected some genres like action, adventure, horror, and romance. And we can observe that some patterns, for instance, romance tends to peak around February, align with
The coincidence, yeah.
Valentine, right? Yeah. So while horror are noticeable activity around October and consistent with Halloween.
Very good.
And this gives us insight into how genre release strategies might align with cultural or seasonal events. Next page. And here's just the box plot for different months data. So the box plot on the left shows average rating by season. We can see that ratings are relatively stable, with 4 slightly higher than the others. And on the right, the box plot shows number of ratings. Here, spring and summer movies receive more ratings on average. I think it's because summer vacation and the winter vacation. And overall, while the difference in rating are small, popularity shows strong seasonal variations. Yeah, and that's our presentation. Thank you.
Thank you, guys. Thank you, guys. Very excellent job. I think you guys went very long, and I think it's okay for now because it's the first challenge. I think later on you guys be able to tone down a little bit. I think just for everybody, right? So in general, you realize that there are many slides where you can go fast if other people show the same material, so you can focus on the things that you have in your presentation that others don't have, which are more specific to you. But yeah, I think you guys are going to become great at presenting. Okay, I think it's very good job. We take a break now since almost an hour. I just wanted to share a couple of thoughts here because, of course, this is what you're doing now is already archaeology, right? So this type of data will never happen again, right? Because now we have bots, and the bots will try to shape the public opinion regarding a certain movie by interacting with users, going online, leaving comments. So of course, this type of view of the people's opinion is no longer available to us, right? And the other thing is that the information that you have now, will never be made available again, right? Because all these streaming services, very famously, they don't release any statistics. They don't release any statistics of the watch time, and because basically the deal that they have with the producers of the content they steer away from the popularity because they don't want to pay for a movie based on the views that it has. Okay, so because famously in Hollywood, right? So you will have if you're an actor in a movie, you can ask for a share, and then you will get a certain amount of money of the ticket that people pay to go see the movie. But of course, this doesn't happen anymore, right? So Netflix, you pay a subscription, and then how this subscription turn into revenue for the people that produce the content is completely obfuscated because, of course, they don't want to have any deal in which people are rewarded excessively, right? So they release all this. They keep all this information very close to their chest. So yeah, I think it's incredible how things changed since the release of Netflix. Yeah. Okay, very good, guys. So let's take a break. Let's come back at 37, 38, and then we go with the next group. Okay. If you have any comments, just click the chat. Okay. Ciao, guys. Walk around, drink some water, stretch your legs. See you in 30 minutes. wash my clothes. Hello, guys. Very good. Very good. Any comments for group think tank? No, team tank. Otherwise, we move to the next team, which is Pioneers team. Come, guys. How are the Pioneers?
Hello.
Hello. Are you guys
There we are.
excited?
I will share
Hello.
my screen. One moment.
Very good.
Share.
As I said, like if you have some slides that we saw before, don't worry. Just feel free to go to it quickly so that you can focus on
I
the things
have
that
skipped some, like, we have skipped together the important or like the first ideas because we thought we only want to show you the main findings of us.
Of course. Go ahead, guys.
We have already done that. Our names are Tsuan Hunkai and my name is Wiegel Rickert, and today we will show you our results. We first... Or do you want to talk first to me about how the progress is going?
Just you do it. You do. You do.
Sorry, what did you say?
Can you do the progress explanation?
Sorry. Yeah, we did we met like last week for the first time. We met Thursday. And furthermore, that was like a meeting in person. And furthermore, we did yesterday an online meeting, and today before class, we did as well an online meeting. We have
Excellent.
We have one group mate who showed up last week in the Slack app, and I added him to the Line app, and then he typed some things and he chatted, but now he hasn't worked on anything and he didn't say anything in the group's chat. So we have assigned him tasks like the challenge questions 4 and 5 were assigned to him for this project, but he didn't do anything, and I don't know who he is and what he has done, or even if he has done something. So we still have to do challenge questions 4 and 5. We will do that later today, I think. But furthermore, the progress is good and the teamwork is good as well.
Very good.
Let's go further to the key findings. The key findings we had, like at level 1 was mainly that drama was the most popular genre, and behind drama was comedy the most popular. That is like in general the information we want to say about our level 1 findings. Then we go, and the genre box plot, sir.
I added the general box. I've added the general box plots because I want to show the mean value and median of how does the schoolness as look like. Because as the graph see, the drama have a highest median, but from the relation of the mean and median, we can see that it was obviously school right. Right? Yeah, school right. So it can show that the drama even have a highest median rating, but it was not that symmetrics, or we can say it's not that, how do I say, balance, something like that. Okay, next please.
The key findings at level 2. In our first research, our key findings were mainly that the average moving rating by release year is quite constant and is slowly in a downtrend. Our hypothesis for this is that movies are more available for people. People went to Netflix and DVD, so it's more available for persons, and they will rate it lower. Furthermore, you see a spike in the average moving rating from films in 1902, I think. It's something like that. We can declare this by the fact that the sample size is really slow, so it will be very volatile. This like from 1800s in the the late 1800s till the 1920, because the sample size of ratings is really small. Then I want to give you the word. Go, Jack.
Okay, so, and now this part is just a general knowledge of top 20 texts per movie, and we can see that BDR was the highest and the most common text for all of the movies. It has got that 2,300, something about that. It's about 1% of all of the movies. Okay, next page, please. And then we do the text count versus the rating. And I do two versions, which is the text count versus rating count, just only the number of rating. And then the second version, which is the text count versus the rating with the actual value, which is 0 to 5. And from the graph here, we can see that the R, which is the relation between the text count and rating count, is about 0.7, which means that it has a positive, relatively strong positive relationship between text and rating with a pure number. And the next page, please. And for the text count versus the average rating, which is actual value, we can't see the relation between the text count and it, because it's only got the 2.221 relation. Okay, next.
And here, this is we have to find the most agreement general movie and the most disagreement general movie. And to see the average rating, we see that File Nor is the most highest rating, and the non-general list is this. And also we can see the number of rating by general. And next page. And we also find the variance of rating by general. And we concluded these three things into this part. This is the average rating of movies by general, with 95% confidence interval. So we can clearly see that the Film Noir is the most agreement movie, and the general list is this. Okay.
Yeah.
Next page. And here is we have to find a single general vs multi-general movie. So to using the same method, the confidence interval, we can calculate confidence interval and turn into this graph. And I think the static is enough to do these six. So we can see that the single general movie is more has better ratings. Yes.
Then we have also done some research to the top 5 genres per decade. The sample sizes for we have taken the decade from 2000 and the decade of the 90s. The sample sizes for the 2000 decades are almost half of the sample size for the 90s decade. You see that the most popular genres are common, like comedy and drama, only switched around. We can declare this by the fact that it's more DVD based, and besides, there were some tragical things during the 2000s, like 9/11 or other things. Furthermore, we have done some research to user rating variance versus genre diversity. There is no correlation or there's a negative 0.1 correlation, which is almost no correlation between the user rating variance and the genre diversity. I didn't thought this would be the result. It's quite counterintuitive, but yeah, that are the results.
Okay, and now it's my turn. And this part is just briefly talk about the text between the relation between text and genre. So this one was about the action. So and the next page, please. This one was a horror. Next, and this one was a romance. And the last we have yes, this page. This I do a stack bar to represent the relation between each genre and to see how is each text shows about the most important. So we can see that in the original one, which is three origin and great ending have three the romance, horror, and action all have this text and all have a relatively high relevance. And the other thing is that we can see that from the stack bar we can see the romance and the action have more relation between horror because from the mentor, dialogue, and catastrophe, we can see that they both share the same text. So I'll say that they have a more relationship than the horror movie. Okay, next page. And now we do this one was trying to figure out the relation to compare the relation between the distribution of user assignment take and the relevance from genome scores. So the way how I did this is I use randomly to pick 2,000 data from the movies, which is about 5 to 10% of all the popularity, and then just doing the overlap of it. So from the graph of the right graph is just a count and overlapping, and the left one was the box plot of overlap of user top 10 and genome top 10. And from this graph, we can see that there's not that relevance, not that much relation between user top 10 and genome top 10. There's only median was only less than about 2. So this was not that much relevant. Okay, next page.
And here we have to find a co-star movie. So we find 20 movies with few ratings and high take relevance. So here is the 20 movies, and we think that this one movie ID EE11AAA may have better future success because his rating is high and his number of takes is high and ratings number is relatively higher. Yes.
So maybe next time put the title of the movie instead of the ID. You know, like humans tend to remember words, to remember the title of the movie better than the movie ID in the dataset. Okay, so then we know which movie you're talking about. Right?
Oh, because the name is too long.
Okay.
Maybe that's why.
So now this part was the stretch goal of the first point, which is to create a simple baseline predictor. And the way how I create is using the weighted. And so 0.5 times the movie means, which is the trend set. And the other 0.5 was using the identical general movie. And the weight is considered by the standard deviation of it. Because I think if the more concentrated the movie's tag is, it should have a more weight than the others. So I use the standard deviation to consider about it, and then evaluate the RMC on the 30% of the whole set. And from the results, which I use the 3 results to represent the different sample numbers. So the first one is a Toy Story with about 40,000 samples or 50,000 samples, and the predict baseline 3.57, RMZ was 0.96. That was not that important, but from the target movie 1 and target movie 3, with a huge difference on the sample base, you can see that the RMZ have a huge difference. So which can represent that if we wanted a more accurate baseline rating, we must need to have a huge amount of a sample. Okay, next page.
Now we have done as well the KNN future select, KNN neighborhood regression. We try to predict the predicted rating. We did this on the basis of 2 futures named movie efforts rating and user efforts rating.
Yeah.
We did it for, they had both the same weight of 1, so they were equally important. We did it for K is 1, K is 5, K is 10. You see almost K is 5 and K is 10 are almost the same. Furthermore, we did it for the metric Euclidean, metric Manhattan, and the metric cosine. You see the results for metric cosine are not that useful. That's because the metric cosine only accounts for the direction and not for the magnitude. And we are looking for the magnitude between both ratings. We think the KS5 metric is Manhattan. The Manhattan metric with K5 is the best KNN
Hyperparameter choice.
What, sorry?
I said hyperparameter choice.
I think I had a parameter choice 0.6 or 0.5.
Very good. Very good.
And furthermore, like you can see, when the movie efforts rating and the user efforts rating is high, they predict as well a high rating, which is like what we had expected. This is a frame with the test data inside. You see, the tested data are the black points, and you see, like, based on these data, they predict this heat map. And that was our presentation. Thank you for listening.
Okay, thank you guys. If you have any comments for group pioneers, otherwise we go to the next group, which is the challenger team. Yeah, challenger team, are you here?
Hello. Do we hear me right?
Yeah.
Okay, perfect. So my the leader of the group was supposed to make the presentation, but he won't be able to attend the course today. So he made a video of him presenting the presentation.
Very good. Go ahead. That's the spirit of a leader. Yeah. Go ahead. So when you share the tab, you have to click the audio, right? You know what to do.
Excuse me, I didn't understand.
So when you share the tab, you have to click the audio little button, right?
Where?
So when you click the sharing, right?
Yes.
In your Google Meet.
Okay. Excuse me. I'll do the presentation again.
Share a tab in Chrome, and then at the bottom of the window there is a little check mark that you want to share the audio.
Okay. Where is it? It's in here?
No. Listen to me.
Yes, I'm listening to you.
You click on the sharing tab. Click the sharing tab.
Yes, this one.
Go ahead. Let's see if we have the audio. Otherwise, we don't need to discuss it. Yeah, so there is no audio. So go back.
Okay.
So there is the button with the computer and the arrow. That's a sharing tab. Okay, you click that one there. then you share, and you decide to share, stop sharing, and you share a Chrome tab, okay?
Oh, okay.
When you click on to share the Chrome tab, if you scroll down, if you look down, there is a check mark to share the audio.
Okay.
You found it?
That because I'm not on Chrome, I'm on Firefox, so the interface is.
You have to use Chrome to share. I only know that you can share it in Chrome. I know that you can share it in Firefox.
Okay. Maybe if I directly, yeah, if I put the screen instead of the.
Or you can send the video to me. I'll share the video. Okay. That's
Yeah, it's easier. Okay, perfect. Thank you. I send it in the chat.
You can send it in chat. I think it will not mind if we all look at his YouTube channel, unless he's been publishing
I hope no.
videos of him playing snooker for money, or I don't know. Ba-ba-ba-da-bum. Ba-ba-ba-da-bum. Share Chrome tab, and share audio. Okay, you guys are here with me. Let's enjoy some YouTube together.
Today we'll present our explosion and analysis result for challenge 0. And here's a basic explosion. Overall, the most common rating is 4, showing that most users tend to have positive scores. The largest genre is drama with about 30,000 movies. The median number for rating per user is around 68. For the top 5 genres, median rating mostly fall between 3 and 4. Rating activity peaks in 2000s with nearly 2 million ratings. While volume fluctuation, the yearly average remains stable between 3.4 and 3.7. By release year, film from the earlier 20th centuries show average close to 3.6, reflecting the sample size bias or performance for classics. On long coordinates, the number of tags and ratings shows a positive correlation. Popular movies have both more ratings and more tags. Most movies have only 0 to 5 tags, but a few popular ones have dozens or even hundreds, creating a long tail distribution. Frequent tags include sci-fi, based on the book, comedy, and actions. For genres with more than 1,000 ratings, the highest average is film noir, and the lowest rating is horror. Single-genre movies and multi-genre movies also show slightly different rating distribution, reflecting different audience perceptions. The 1940s have the highest average rating, while the 1890s are the lowest. The top 10% of active users contributed over 9 million rating with an average of 3.39 compared to the 3.64 for regular users. These show variation across decades and users group. Without the filter, film noir and documentary appear highest, but this is skewed by small sample size. Within larger than 1,000 ratings, mainstream genres like drama and crime movie up. This highlights the importance of controlling the small sample bias. The top 10 users provide far more ratings than others, with average closer to the global mean, showing stability. Casual users give higher score, often rating only favorites. While both groups peak in the evening, heavy users remain active between midnight and 3 a.m., suggesting they sacrifice sleep for movies. Okay, for question 3. Frequent tags are bored, like action, comedy, and drama, but show low genome relevance. Some popular tags like Pixar or time travel are common yet not discriminated. In contrast, rare tags such as neo-noir and existentialism are highly relevant. The plot shows the frequent tags cluster at low relevance, while niche tags carry stronger semantic power. And this is the
Oh.
our result for question 4, 10 in movie runtime. Movie runtimes increase over time. Earlier film was short, but as technology and storytelling evolved, runtime stability around 19 to 120 minutes. This reflects the balance between narrative, completeness, and audience attention in modern cinema. And here's all of my presentation. Thank you.
So by the time he did the video, our work wasn't totally complete. And to be honest, it's still not totally complete because at the beginning we had a hard time synchronizing with each other. So we are really sorry for that. But
I
yeah.
think it's dynamic. Like people tend to work toward the end. Yeah. You're French, right? Am I correct?
I think you can tell by
Can
how
you give the correct pronunciation of noir?
Noir, excuse me. Yeah.
See, that's how you pronounce it, guys. And since you're French, you also can give us some example of film noir, right? Go ahead.
Of film noir. I know the genre, but because it's a very cinephile subgenre of cinema. But I don't know if I can really bring to you a film noir.
Cahiers du Cinéma, is it from your
yes, I know by name. Les Cahiers du Cinéma, maybe movies from La Nouvelle Vague. I don't know if you know Godard and others.
Any titles that you remember from the?
The one with the famous actress. I saw it in cinema, and she's naked like half the movie. No, really, I don't remember the movie. It was not really great, to be honest. Godard, let me find this movie.
That's why you don't.
Le Mépris. Yes, exactly. Le Mépris.
Le Mépris.
Le Mépris. I don't know what it's the translation of Le Mépris, but yeah.
No, well, that's. But guys, go watch this movie. Not because there is a half naked woman for half of the movie. Okay, just for your own cultural development. Okay, go ahead.
And yet.
Not about the naked one, about the presentation, please.
Okay, excuse me. So I was in charge of the 3 first challenge questions, and so I will be able to only talk about this one. If you have questions or remarks. So I decided to add a plot for the first challenge question. And it was which one? The one, yeah. So we can see that high averages rely on very few ratings.
Just a second, you have to go back to share your PPT. You're not sharing it.
I know. Excuse me. Yeah. Maybe you can put the video. It will be easier for everyone.
Oh, so you don't have access to the PPT? You want me to share the video again?
Yeah, because the leader just sent us the video, not the presentation.
Okay. Good. This one here. Good. Tell me where to go. Yeah, which minute to go?
Yes, it's 2.5.
2.5. 2.5. Good here.
Yes, exactly. So that wasn't required, but we added it to highlight the fact that most of there is a correlation between the average rating and the number of rating, and so we wanted to highlight that on one plot and to put the number of ratings and also the average rating, everything on the same plot. For the next question, the hourly rating activity. So we wanted to study if top users. So we took the 10 most active users of the data set, and we wanted to check if there was different behaviors of rating. And so as we can see, everyone picks in the evening, so after work or things like that. But Power User tends to show clear late night activity. So I don't know if the Power User works in the morning, but they
It doesn't look that way, right?
yeah, exactly. It doesn't look like that.
They sleep in the morning, yeah.
It looks like they sleep from 12 to 15, and they watch movies from 0 to 3 a.m. From midnight to 3 a.m. And I think, yeah, for the question right after, we try to use clusters, but I think that the visibility is not premium optimal. But the goal was to highlight the fact that niche tags were infrequent but highly informative, like for example neo-noir or minimalism, and users tends to give a lot of tags that are not relevant to qualify movies, and yeah, that's it for my part.
Okay, very good. Anybody else from the team? You guys were 3 people, right?
We were 4 people.
4 people, okay.
Yes.
So anybody else want to say anything while I'm sharing the PPT, guys? Yeah, that's it, guys. So try to do a more complete job by the submission of the final 5, okay?
Yeah, no problem. Thank you very much.
Okay, good. So let me write down in my notes. I can write bit incomplete, but interesting insights. Very good. So now we can talk with, we have Error 404 team. Come on,
Hello.
guys.
Hello. Yeah, let me share my screen. No, that's the wrong one. What is? Oh, I like this. Okay. Oh, now I get it. So, can you guys see the see the slides? Okay. So, this is our presentation from Error 404. We didn't find any Python errors because we're so good at programming. So we will stick with the name Error 404, I guess. Start with a brief outline because I won't be starting by talking, but we will first be talking about the highest average rating. So this would be like challenge question 1. With and without a threshold, and then how often people rate. Then thirdly, the temporal changes for the average rating for different users. So if you for the super users and for the new users, then we will have a little interlude about tags, then talk about decade differences, and then talk about genome tags. And yes.
Okay, so I've worked on the level 1 and some challenge questions. And while I was implementing the analysis and plots, I noticed some interesting patterns I wanted to share. As for the slides, you can show 2 views of average ratings by genre. On the left, I computed the average rating for each genre using all movies. On the right, I recomputed the average after applying the thresholds, which is over 1,000 ratings. And as you can see, the top genre overall is film noir, both before and after the thresholds. So the ranking did not change when we required at least 1,000 ratings. And a few other genres moves around a little, actually just 2, but the top positions is stable. So for me, I think that the stability suggests that the highest ranked genres are not just an artifact of a few obscure titles getting extreme ratings. They persist even when we focus on broadly rated movies. Okay, next slides. And now I want to see the drop percentage by genre. This plot quantifies what the threshold filter actually removes. For each genre, I compute 2 numbers. So the blue bar shows what percentage of that genre's movie are dropped by the filter. And the green bar show that what percentage of that genre's ratings are dropped as a result. As you can see, most genres lose a large fraction of their titles under the filter. For many genres, 70 to 90% of titles are below 1,000 ratings. And that's expected. Most movies are relatively obscure. But one genre stands out. That is documentary. As you can see, nearly all documentary titles are dropped. Yet the green bar shows that we'll still lose about 40 to 45% of that genre's rating. So in plain terms, documentary has many, many low volumes titles, and these collectively counts for a non-trivial share of documentary ratings.
Could it be also because it's the cheapest to produce? Probably, right?
Yeah, probably.
I mean, you can also see that IMAX is the which would be all the high-grossing movies are released on IMAX, and that's the one that's dropping the least.
Right, because it's the most expensive one.
Yep.
Yeah.
Actually, in this data set, IMAX movies has only have 145 movies.
Because it was the beginning of the technology, right? So, yeah.
Yep. Okay, next slide.
Very good, very good.
Okay, on this slide, I want to show distribution of numbers of ratings per user sorted by most to least. So we can see this curved line. This key takeaway is that the mean number of rating per user is only 144, but the distribution is highly skewed. A very small number of users contribute an outsized amount of ratings. So in other words, most users rate only a handful of movies, while a few users are extremely active. So because of this, Heavy Tail decided to investigate those top contributors in more detail to understand whether their behavior is normal. Okay, next slide. Here I examined the 3 most active users individually. This small plot shows daily ratings for a user over time, and the table summarizes their most birthday statics. So now I'm going to explain these little words like birthday. Birthday is the single date where the users made the largest number of ratings. As you can see, the user 118205 has 1,012 ratings in one day. So it's really crazy. And as for 82418, he has 626 ratings. Another peak rating per minute is the maximum number of ratings that occurs within any single 1 minute window on the birthday. So as for me, I think that human really gives 10 to 15 ratings in 1 minute. If it's over this number, maybe it's suspicious, you know? Yeah, and another thing I want to explain is the percentage of inner rating intervals that are less than 10 seconds on the birthday.
I see.
Yeah.
I see. So I think there was some early bot, or what do you think? Yeah.
Yeah, maybe I think there's some bots, or they just don't care what the movie was, and they're just rating it what they want to.
Because you can rate per memory, right? You can rate per memory, let's say, but
yeah, maybe like they really watched so many movies, like they all remember. Okay,
I mean, 2 of them are also just in the start of their, so they created an account, rated all the movies they've seen, and then they probably used the site after that and rated when they were. So I mean, they're still active, so I don't think it's botted. I just think it's they created an account, rated all the movies they've seen before, and then slowly used their account later.
Yep.
Yeah. Because you know this. This was also the beginning of this type of mechanics, right? The people really get into, you know, some people. I want to say this, right? For example, Stack Exchange. Have you guys used Stock Exchange? Like math.
Yeah.
So there are some dynamics in which you have power users, and power users, they really fight for the status of power user, right? They really go and answer all the questions, and they really try to get. So at the website at this point, there was no acknowledgement, I think, for power users, but maybe people they will really maybe go and check how many ratings one has given. So maybe some people really wanted to have a very high status over the website, so they went crazy trying to gain these very crazy numbers. Yeah? I want. Go ahead, guys. Go ahead. Yeah, there are many interesting things. Yeah. Go ahead.
Yep. So to understand whether this is a phenomenon only for the extreme few, I compared the 3 groups: the top 10 people, the top 10 users, the median 10 users, and the bottom 10 users. On this slide, compared 3 groups of using 5 metrics: mean birth size, share, the percentage of the user total rating occurred on their birthday, and the mean peak per minute and the percentage of the things, and the sus rates. This is the fraction of users in the group meeting are suspicious criteria. As for how I decide suspicious criteria, my threshold settings is most ratings in 1 minute is over 15, and the percentage of time less than and equal to 10 minutes is over 70%. It's quite suspicious. Okay, so with these 2 thresholds, we can estimate whether the user is suspicious. Okay, you can see from this graph, the top 10 users have dramatically large birth size. As for the median 10s and the bottom 10s, they're not that high. You can see from the mean peak per minute, the top 10 users is nearly 2, as like 14.9, while the median 10 only have 7.7 and bottom 10 8.2. And another thing I would like to say is that you can see that the share percentage, you can see the median 10 and the bottom 10 has very, very high share, which means that they actually just comment 1 day of ratings, and they comment all the movies that I've watched. So this is a really cool thing to see. Yep. Okay, next slide.
Okay, so we're onto the temporal changes part, and we've sorted the ratings by year, and we graphed it on the chart. You can see the graph on the left is the ratings per year, and there are 3 peaks we talked about before. But what's rather interesting to us is about the decline in numbers of ratings per year ever since 2008. And upon my further research, I found that the timing of decline actually matched the downfall of one of the most iconic and largest video rental shop in United States, which is Blockbuster. Their decline also started during 2008 to 2010. And by the downfall of Blockbuster comes the uprising of Netflix and other video on demand services. And I think here why the ratings per year drop here is because that those services like Netflix, and they have their own system of recommendations, so people will less likely to use these sites for recommendations. So there's lesser ratings on this side ever since.
Very good. Very good. Well, go ahead. Do you have something else to add, guys?
Yeah, I thought you were gonna talk about the average rating, or do you want me to shift slides? Sile?
Yeah, and on the right is the average rating per year. And there isn't too much of significant changes in the average rating in terms of the year. So we can see the trend is pretty consistent here, roughly averaging at 3.6 or 7-ish.
Okay.
So here we then sorted the average rating by different groups of users, like the super users and the new users. And we can see on the chart, we can see there are actually there are different different rating trends for like user who rated lesser movies and user who rated a lot of movies. There are different trends. Especially you can see that for the n equals 20 users, which is the minimum we can find in the data set here. We can see there is like a significant rise in 2014 and 2015.
That's weird, right? Because the total number of ratings is going down, but the average rating is going up.
And on the right-hand side we have the MSE of the user groups compared to the super users we mentioned before here. So what's more interesting is that the lower percentage part of the users and actually has lesser MSE, just like the higher percentage of the users, while the middle part of the percentage users has a higher MSE compared to those two.
Next, moving on to text usage. I believe this was previously mentioned by the other groups, being sci-fi and based on books being the two most popular text used in the dataset. And also a similar scatter plot, which previously was also shown, showing how there's a positive relationship between the number of text and the popularity of the movies.
Can I give you a suggestion? You are speaking
Yes?
a little bit. I think you're speaking a little bit too fast. If you can slow down,
Okay.
it helps my slow old brain.
For sure. So yeah, I think that is quite intuitive regarding the popularity. A more popular movie will definitely get more text in general. So that's all. Next slide. Okay, similar to what was previously mentioned, but ratings by decade depicted in bar plot and also consolidated form. So previously mentioned, there's a great dip in a sharp drop in the number of ratings in 2010s as compared to the 2000s. So due to, aside from on-demand streaming, there might also be other alternative platforms such as social media or Rotten Tomato, which attributes to the fact that which are possible alternatives for IMDb, where the dataset is achieved from. Despite this, there's still a similar average rating across decades. So 3.49 in 2000s and 3.55 in 2010s. Next.
Yeah, I was also wondering about Rotten Tomatoes, right? Because when they emerged, there was this idea that they had they would predict some of the users' rating. So I think they had the idea that the ratings were fairer because they had this tomatometer. I was also wondering. Yeah, go ahead.
Okay, next, moving on to genre prominence, comparing 2010s and the 2000s. So from this graph, you can see that drama, comedy, and action are still the top genres across decades, showing how timeless they are. And one other thing that I noticed from this graph is the spike in IMAX in the 2010s. Yep, due to improvement in the visuals and tag accordingly. Yeah, that's all from me.
Okay, then we're gonna talk about the genome tags dataset that we got. In this dataset we had two types of tags. We had the user tags, which we can give not a relevancy, but use to determine what the movie is going to be about by how many times it has been tagged with, say, comedy. So this is an example movie. Mrs. Doubtfire just took a random ID, and that's what it happened, which is by the user tags we can see that it stars Robin Williams and Pierce Brosnan. It is about cross-dressing and about a nanny. And as far as I remember, because I think I have seen this movie, it is Robin Williams dressing up as a nanny in a family and that's going through some hard times. But if we look at the genome tags, which was in this dataset that has the amount of relevance to the movie that a certain tag has, we see that it's probably a kids movie, as there are children. You can see that it's also about cross-dressing still, and a single father, which coincides very nicely with the divorce. One thing that's quite funny is that funny is listed, and in the normal user tags, not funny is listed. So there's some something that goes against the grain there, I guess. But what we then want to do is not only look at one movie and not only and also look at the genres and see if we can use these user tags, the ones that actually the amount of user tags, the user tags that are on movies, use the genome tags to see if we can find a relevance between genres and tags. So we created a heat map where
can you go back a second? Yeah, no, just thinking. Yeah, here I wonder, right? For example, which of these tags, the prevalence of the tags through time, right? This is the only movie about cross-dressing that I think has entered the mainstream media in the past 30 years.
I think I've watched one in high school in my English class that was also about cross-dressing, but that was a little bit more serious, maybe a drama.
Exactly. This is not the way in which they describe cross-dressing here. I think for modern sensitivities would be terrible. Yeah, I think it's.
Yeah, it probably would.
San Francisco, San Francisco, that I don't remember.
There's also a thing I forgot to say. You can also see that the user tags that people use compared to the relevant tags in the data set is that the user tags are maybe a little bit more noisy. They maybe not have as much to do with the movie as more something that is readily apparent. So say, which actor is it? Pierce Brosnan, Robin Williams. Where is it based? It's in San Francisco. And then also, of course, there's duplicates in this data set. So cross-dressing and cross-dressing men should probably be counted together. But we didn't, that's a little bit hard to do. So yeah, but we went over to the relevance of tags in different genres, where we have this heat map here, where the third axis, the color axis, is the relevance, and then on the left side you have the tags ordered from the most common to not the least common, but just the 18th less common, I guess you could say. And then here it is drama. It is drama that is the most common genre, and then going all the way down to IMAX. First of all, we can see some apparent tags that have no relevance on the absolutely no relevance, such as time travel. But apparently it's still tagged a lot. So there must be a lot of movies which maybe feature time travel, so the users tag it with that. But the time travel is not that important to the plot or whatever is happening. Maybe it just is in the future and people will tag it with time travel, as an example. We also see that there are a lot of, again, not noise, but you see that the action movies are are getting tagged as action, which is good. We see that that at least means that my code is working. Then we have that, for example, we've been talking about a lot about this film noir. What is it? A lot of the people presenting before us maybe didn't know. But here we can see which tag is actually describing film noir. So it's very visually appealing. It's very stylized. These should go together well, as stylized is usually leads to being more interesting to look at. It's surreal and it's atmospheric. That's what film noir is usually categorized. It's also some psychology, and knowing film noir movies myself, I would say that fits with my idea of it, at least. Usually they're called film noir because they're in black and white, so that would be stylized. They're visually appealing as they're made by movie directors that care a lot about the cinematography, and so forth and so forth.
So now you expose yourself, right? You have to tell us about some film noir, since the French.
I think I don't think I can talk about any French film noirs, but I would say that the one that I think of the most is Blade Runner. that is a sci-fi film noir, but it's still very film noir in the way that it's shot. I would say, at least, and that's what I've heard it described as. So that's my idea of it.
Give me another one. Give me another one.
7.
You would consider 7 as a film noir?
Yeah, it still has a little. It's also usually crime and mystery, which can you see that in this? Where is crime even on this? I guess the psychology you can say. Disturbing is also there. So I mean, I would say that's what I can mention. Sorry, I am so much of a film buff. I am not.
Because we have some hot takes, so I just want to see how much.
I would not call those hot takes, but yeah, sure. Yeah, and then you can also see tags such as twist ending having a lot of relevance in, again, things you would expect them to. So thrillers, horrors, and crime and mystery. These all make sense to have twist endings. One thing which I've forgotten to make a slide is based on a book. One where it has relevance in most genres, but I would have thought that at least fantasy and sci-fi were some of the more popular ones. But yeah, fantasy is popular, but it's not the most popular one. War is actually the most popular one, which I find interesting. Yeah, I think that was about what we had to say.
Okay, very good, guys. Very good, very good. Very good. Yeah, the last two groups, a good job on coming up with your own take on the questions. Okay, I think that's what I would like to see, right? Especially when you present like this, since we all go one after the other. If you try to make your presentation more yours, so talk about something, your take on the challenge, I think it's more compelling for everybody. Okay, last group. 学习 team G 学习。
we're called 机器学习。
机器学习。
Yeah. Okay. Am I clear?
Very clear.
Okay. Wait a second. Okay. We're group 机器学习, and this is our Q mascot. He's Courage, the cowardly dog. Okay. And right. I'm kind of laggy. Am I? Okay. This is our mascot. This is our presentation overview, and we divided this presentation into 4 different parts. And level 1 and 2 is for Hong Wei-Chen, and level 3 is for Zhen Lici, and challenge question is for Barry. And my name is Will, but you can call me anytime. And my part is Transformer, and that's our feature. Okay. So next part is for Hong Wei-Chen.
Yeah.
Okay, so now I'll go through the dataset overview. So for the dataset overview, the number of ratings is around 20 million. The number of tech users is around 465K, and number of movies is around 27K. Number of users is around 138K. Okay, so next slide. Okay, so for the next slide is the rating distribution. So as you can see from the graph, the rating distribution is unimodal with the mode at around 4.0, and the rating cluster is between 3 to 5.0. And this is a very less skilled graph with the longer tail towards the lower scores, and the mean is around 3.53. Next. So now we move on to the top 10 genres overview. So as you can see, this top 10 genres is dominated by drama and comedy, and there's a very steep drop after the top 2, which the rest is very low amount as compared to the top 2. Then for the top rated is film noir, documentary, and war. Next. Then now we will look at the trends over time. As you can see from the top left graph, the volume peaks at around early mid 2000s, reflecting performance growth and catalog extension. However, for around the same timing, around 2000s to 2010, the average rating dipped. This divergence between the count count and min implies changing user mix or movie mix. Basically, there might be a influx of users that are more that expect higher quality of movies or more in their ratings, which tends to give lower score, or generally the movies are just of lower quality. Yep. Next.
In the 1990s, rating volume was low and more volatile, while in the 2000s, it was consistently higher, peaking around 2000 and 2005, before gradually declining toward the decade's end. Rating in the 1990s averaged around 3.5 to 3.7 and stayed relatively stable, whereas in the 2000s, they steadily declined from about 3.5 to 3.3. Users in the 1990s were more generous with scores. In the 1990s, newly read movies start with very high initial score, before dropping and stabilizing around 3.1 to 3.2, whereas in the 2000s, initial rating were consistently lower and trend downward, eventually falling below 3.3.
That's a good point, because maybe at the beginning of the website, right, the people rush to join the website, and so they just rank the movies that they chose to rank. But then as time went by, they had this daily use of the website. That's also we saw with the other group, right? That some of the users, they just join the website and just give all their ranking in 1 year. And so I wonder if they preferentially rank the movie that they like because they felt more compelled. Yeah, many stories. Very good. Go ahead. Very good.
So let's start look at this text, starting with this picture. What they show is a classic long-tail distribution. A few tags like comedy or action are extremely popular and appear thousands of times. But once you move past those, the frequency drops sharply. Most tags are used just a handful of times, maybe once or twice. Now here's the challenge. User tags don't always align with the geno tags. Users love labeling movies with things like dystopia like Mad Max or time travel like Back to the Future. These are fun, they are common, but in the geno framework, they are not considered highly relevant. On the flip side, tags are really matters for classification. Like great endings aren't used much by the users. So the big takeaway is this: tag usage is highly uneven, and there's a clear mismatch between user creativity and system-defined relevance. And of course, sometimes tags are just funny. Imagine if half of the tags are for the Matrix were simply Keanu Reeves, accurate, yes, entertaining, yes, but for recommendation, not very helpful. Okay.
Okay. And we do some recommendation, and this is KNN for recommendation. And we text everyone's rating and build a big table. And for any movie, we look for K most similar movie. And similar means they were liked by the same people. And for a user, if they use movie A, we pick A's nearest neighbor, like B or C or D, and combine the user's rating on those neighbors to estimate how much they would like a new target movie. And we do this for all movie. We do this for a movie that user haven't seen and rank the score and recommend the top K. And KN is very easy to explain. And we conclude this sentence. KN recommendation, movie recommendation is like we suggest this because it's like the ones you enjoyed. Okay. But KNN got some drawbacks. Like the first one is cold start pain. KNN needs interaction history, like new or long tail movie, or maybe even brand new user don't have enough data. So the method can find a reliable neighbor. And the second one is popularity bias. hit co-occurs with everyone, so they look similar to many things and get recommended too often. So to overcome these two questions or drawbacks, we use another method called word embedding. For those who don't know word embedding, here are some know-how of word embedding. Like these are called words, right? Apple, bat, cat, dog, elephant. And we sometimes use one of n encoding or so-called one-hot encoding. But every word in one-hot encoding is equally far from every other word. So the model can tell that dog is closer to cat or closer to apple. So we use word embedding instead, like this. Using word embedding, we can see run is relatively close to jump, and dog, rabbit, cat are closer, tree and flower are closer. And how do we achieve word embedding? We use SBERT, like sentence BERT. And the logic is like this, the training text. This here is writing 蔡英文宣誓就职. 蔡英文 is our former president, and 宣誓就职 means swearing in. So 蔡英文 swearing in. 马英九 also our former president swearing in. Although expert might don't know what 蔡英文 and 马英九 is, but they see swearing in connected with 蔡英文. So expert might put 蔡英文and 马英九 very close. So we build a movie text. I'll explain what a movie text later. We build a movie text. It represents movies, and we put it in like this. So here are many kind of movie, and we build another user vector. User vector is for user, we collect their positive movie. So create a user vector and do dot product to those movies to see the similarity. And I do normalize those vectors. So if you want to do dot product, just do the cosine of it. So it will be dot product because these are all normalized vector. Okay. So what a movie text is. Movie text includes movie ID, title, genre, and text. Like movie 593 is movie ID, and title is The Silence of the Lamb, and genre thriller crime, and tag is serial killer FBI psychological. So we turn these kind of text or into text like this. The Silence of the Lamb, 1991, genre thriller crimes, text serial killer FBI psychological, into SBERT to let it train. And why is SBERT is better for recommendation? Because it understanding meanings, not just words. SBERT turns text into semantic embedding. So like serial killer thriller lands near psychological crime drama. But if you only use like term frequency only matches literal words that overlaps and misses the synonym. And it is co-star friendly. Like I said, KNN needs interaction history. Like new or long tail title can be recommended as soon as they have text, like title, genre, text, blah, blah, blah. But KNN needs interaction history. So it struggle with fresh or rarely rated item. And embedding is fast and stable scoring, because once you embed the catalog, recommendations are just cosine similars, like dot product between fixed size vectors. So it got low latency and easy to scale and very strong to those vocabulary changes. Like this one is data frame or the recommendation I use SBERT to give me. So if you if Professor, you give me your user ID, maybe I can recommend some movie for you, and it will mask the movie you have watched. So like these kind of movie, none of them I've watched before. It's too old for me. I'm too young for this movie, but yeah. So this is our future work or some takeaways. Like Esper still have some caveats. Like you need to have some text. So if the content is missing, you might need to use KNN or Popularity as a backup. And initial catalog embedding takes time. It takes really long, as you know, transformers are very bulky, so it takes time. So what we'll do next in the future is maybe combine the Expert with KNN or the line fine tuning of Expert. And that's it. That's for our presentation. Thanks for watching.
Very good, guys. Yeah, so let's see how much you can do with these transformers. Yeah? Of course, you can take a pre-trained transformer like BERT or something. Let's see what you guys want to do. Maybe next time you tell me because you want to finish it before Friday, I guess, right? Before we have to submit the report, right?
I thought we're gonna submit a report today, isn't it?
Friday we usually submit. So you have a couple of days. So if you want to tell me next time, yeah, you can tell me next time.
Okay.
Yeah, my suggestion is just to take a pre-trained transformer. I just take BERT and just put everything into BERT. Yeah, because training a transformer is very heavy because they have all these layers. So, but most of the time you can just use some pre-trained BERT, and that's about it. And also you have different model sizes. So since the vocabulary here it's pretty limited, you can just take some small dimension. You don't need to go 350 whatever. You can just okay. Very good, guys. Class is almost over, guys. Actually, so I think we take a break. Go ahead with the question.
I think you skipped our group, Group F. Yeah, we still have a presentation to show.
Oh, I skipped you guys.
Yeah.
Oh, okay. So guys. Okay. Sorry. So then, okay. Good. Okay, good. Okay, good. So let's take a 5 minutes break, guys. No, actually, just take a 2 minutes break, right? Let's walk around, go to a toilet, and then we come back for the last group. Okay. Go ahead, guys.
Okay.
We'll see you in 2 minutes. Okay, guys, I'm ready. You can shoot me. I mean, you can present. Yeah. Yeah.
Okay. Just a second, I will share my screen. Okay, do you see it?
Yeah.
Okay, how's it going? So this is Group F. Our team name is Green Color Chili Peppers, and I want to show what we've done for the challenge 0. And first, we're gonna start with the dataset structure. Dataset looks like this, and dataset statistics like this. We have a lot of ratings, 20 million, and some basic information about dataset. Before we plot any chart, we notice that like some of the data on the dataset is used across many charts. So we've done some pre-processing, and these are columns that we added to the data frames. They're just calculated from the columns that are provided in the dataset. So for the ratings, this is the distribution of the number of ratings per user. This one is a log scale because the tail is very, very long, and there are not many users that leave a lot of ratings, and distribution of average rating per user looks good. And then another statistics about ratings is the distribution of ratings is like this. This is the number of ratings, the y-axis, and we see that usually users don't set ratings like 4.5 or 3.5, and they incline into setting integer ratings. And over the year, average rating doesn't differ a lot, and it looks almost like a straight line. And we asked a question: are ratings different for older movies? And yes, they're different. So in the beginning, average rating diverges a lot, but then it's like squeezes into some average rating. And we thought maybe that's because like there are more movies and more ratings. Yeah, so the more ratings we get, the more squeezier the average rating becomes. So
the variance reduces. Yeah. Go ahead.
Sorry?
I said the variance reduces, right? Yes, that's
yeah, the variance reduces. Yeah. And so number of ratings created over time, and we see that like in 1996 there are just a peak of ratings, and also at 2000 and 2005 there were those peaks of number of ratings, and we wondered why we have such peaks. And at first we thought that maybe that's related to the number of movies released per year, but no, we get more and more movies, and it looks like a
exponential.
Yeah, exponentially, but we don't see a direct relationship between these. And
Wow.
then
So here, really, the number of movies is increasing. So even in the between the 1980s and the 2000, they basically tripled the number of released movies per year. Because of course, India came online with Bollywood, and China came online with Chinese industry of the movies. The cost of production went down. That's a very nice plot.
yeah, and this dot is so low, I think, because this is the 2015, and that's the year where the data set was released. So maybe this year wasn't finished yet, or it was the beginning of the year, so this dot is very low. Yeah, and another hypothesis was that at these years, some very popular movie was released, and a lot of users, they tried to rate it. So that's why we have such a peak, but it turns out that not, because in year 1996, for example, we've checked top most rated movies, and those are only these, and they don't have that much ratings to make that big, because top 10 most rated movies are just 11% of the
Wow.
of the all of the rated movies. And for the year 2000 is just almost 3%, which obviously shouldn't make such big here. And for 2005 is the same situation, 2.5%. So that's not the reason of this peaks. And yeah, we actually didn't figure out why those peaks have happened. So these hypotheses, they didn't work. And also there are tags in the data set. Those are some insights about tags. We tried to find a relationship between number of ratings per year and number of tags per year. And looking at these two charts, we don't see any relationship. Yeah, so tags are, looks like they're not related to ratings, but maybe just the variance is very high, and we will see it in the next chart later. So drama is the genre that has most of the tags. Yeah, and those are the most popular tags by the user sci-fi, based on the book, atmospheric. Yeah. Next, yeah, this is the text rating relationship. So each dot number of ratings per movie, number of text per movie. So each dot is a movie, and we have this plot, and yeah, we see that there is a relationship between text and movie. Just the variance is very high because those are very distributed here. But the more text we have, the more ratings also we have. Yeah. Then these are genres. This is the number of movies that have genre drama, comedy, thriller, romance, and this is the distribution of ratings by genre. So this is some genre, and its height is the number of ratings this genre has. So this quite related, because we see that drama is here, comedy, but then action, even though it has a lot of ratings, but it doesn't have that much movies. This is the box plot of ratings for top 5 genres by popularity. Yep. Yeah, and also this is the distribution of average rating for the number of genres, and there is so on this chart we see that it doesn't depend on the number of genres. The average rating is still very the same for any number of the genres, and we've noticed that there is one movie that has 10 genres, and this is movie Rubber. It has action, adventure, comedy, crime, drama, film noir, horror, mystery, thriller, and western genres. Yeah, such a movie, but IMDb rating is just 5.7. So
still 32K, right?
Yeah, still better than half of the movies, I think. Then there is
not me, please. Go ahead.
Yeah, oops. So this is genres and rating relationship. This is the variance of rating, and this is the average rating. And the size of the circles is the number of ratings for a genre. So you see there is like a linear relationship between those. The higher average rating, the smaller variances. And then we compare the prominence of genres for 1990s and 2000s. And we see that in 2000s we have just a lot of ratings, but the mean rating between those 2 decades is the same, almost the same. Yeah, so we plotted 2 charts, and this is just by absolute values. We see that for 2000s, these like orange bars are very high, But if we plot it by ratio, we see that almost no difference.
Good, good, good.
Yeah, and then there is user rating variance, like the number, how many genres user rated, and its variance. So we see that chart. So I think that this chart doesn't tell us a lot. So we try a different approach by using Shannon entropy normalized. And Shannon entropy basically, if value is closer to 0 on the x-axis, it means that user rated only single genre always. But if it's 1, then it means that user rated all of the genres evenly, like all of the genres he rated 5 times. Yeah, and now we see that there is like this distribution, and variance of user ratings has a relationship to the gender diversity because it's all concentrated in here. Yeah, then we've done some work on the genome text. We picked a Pulp Fiction movie, and genome texts are the texts that are generated by movie lens, and those are trained like by some machine learning model, and those are just user texts. Those texts can have some typos, or they can have duplicates. For example, black comedy and dark comedy are basically the same, but we have count for this and count for that also. Yeah, and those two texts, they correspond to dark humor, just the equivalent term for that. And the same story for the other texts in the user text, like Quentin Tarantino and Tarantino. They just correspond to Tarantino, and crime and organized crime basically means the same. So yeah, and also another insight, we tried to apply 80 to find some occurrences of 80 to 20% rule, and we see that top 20% of users contributed 63% of all ratings. Top 20% of movies account for 95% of all ratings, and top 20% of genres cover almost 80% of all movies. So
Excellent. Excellent.
yeah, and that's the last
Yeah,
slide.
yeah, it's very good. Yeah, so
Yeah, thanks for your attention.
Tell me, how many people are in the group? Why are only you presenting?
We have 4 people in the group. We had an offline meeting, and it was just me and one of my teammates. Yeah, and it's only me presenting because other members didn't participate a lot in the challenge.
That's it. Yeah, as I said, guys, please be patient. Of course, the first week of class, we still have people that are dropping out of the class, so bear with it. Okay, very good, guys. The class was really good today. By next time, try to go ahead. There's a question. Go ahead.
We are group H. We haven't present.
So how many groups? So I skipped 2. What's G group H? Go ahead. Group H. Go ahead. What's the name of your group?
5 people.
Okay. What's the alternative name of the team?
We never talk about it.
Okay. Next time you give an alternative team name.
Okay.
Go ahead, group H. Go ahead, but talk to me.
Yeah, let me share our slide.
Twice I thought I forgot about a group today. That's great. That's great. Very good. Share a super long slide set. Let's say super wide. And your cursor is SpongeBob, or it's go ahead.
Okay, we are group H. Hold on, I'm setting my computer.
Okay. Go ahead, guys. I
Okay.
believe in you.
Yeah. Okay, it's good. One more second. Okay. Hello, everyone. We are Group A. We have 5 people in our group, and I'm Wu Zhongrui. I responsible for level 1. Yep.
Right? Go.
Good. My computer is a little bit slow today. Yeah.
Okay.
I'm waiting for it.
You're just changing slide. It's taking so long to change slide.
Oh, I changed my slide. Okay.
Okay.
Okay. Let me continue. And our data set is movie lens 20M data set. My role is to load the 4 CSVs, run sanity checks, keep pre-processing lightweight, so it's use Colab and produce the key visuals that set context for the rest of the analyze. Think of this as the foundation, clean it, and reproducible steps and clear figures that the later parts can build on. And our goals. Our goals are straightforward: understand the shape, quality, and bias of the data quickly and reproducibly. Specifically, we want to know how our ratings distributed, which genres dominate the catalog, and whether genres differ in their rating behavior. The deliverables for this part are 3 figures: rating histogram, top 10 genres by movie count, and top 5 genres rating box plot, plus tidy summary tables for users, movies, and genres. These artifacts become the handoff for trend analysis and modeling in later parts. We work with 4 files. Ratings contains user ID, movie ID, rating, and a unique timestamp. We also derive date, time, and year for time-based analysis. Movies provides movie ID, title, and a pipe-separated genres field. Text hold bears user tags and links gives IMDb, TMDB cross-references. Before any plotting, we log shapes, null counts, sample rows, and D-types. This guarantees that anyone can reproduce the exact same setup. Okay. To stay within memory limits and keep things fast, we parse genres and keep only the primary genre, the first token, so we don't blow up the table. We avoid giant joins by using a dictionary map from movie ID to primary genre, which lets us look up genres in time. We read large CSVs in chunks and use reservoir sampling per genre where needed, so our plots are statistically stable without RAM spikes. All outputs are written to a single folder for easy reuse by the rest of the team.
Very good.
Because we never pay for Google Colab RAM, so we use free version. So that's why we do this. Yeah, budget limit. Here is the rating distribution. It writes good with the bulk of activity around 3.5 to 4.5. Low scores like 0.5 and 1.0 exist, but are relatively rare, forming a long thin tail. The takeaway is that users tend to rate positively on average. For later modeling, that means accuracy alone can be misleading. MAE or RMSE against a mean baseline will be more informative. Yeah, people are just too kind to rate those movies. Okay, the next one is top 10 genres by movie count. This bar chart shows the top 10 genres by movie count in the catalog. Drama and comedy dominate clearly, followed by a long tail. Thriller, romance, action, crime, and so on. Remember, frequency is not quality. If we don't account for this imbalance, downstream models and summaries will tend to overrepresent frequent genres. A simple mitigation later is stratified sampling or genre weighting.
Okay.
And this figure compares rating distributions for the top 5 genres. The orange line is the median. The green triangle marks the mean. Whiskers show spread. Dots at the bottom are lower score outliers. 2 quick observations. First, medians do differ by genre. Drama and crime tend to be higher. Second, dispersion differs too. Some genres are tight, others wider. That's why context matters. A global threshold or a single average can hide meaningful genre effects. And this is my part workflow. Here we look at the count of ratings. Hold on. Oh, that page I missed. This is the end-to-end workflow we use. We load CVS, do checks and clean for shapes, nulls, and D-types. Map each movie ID to a primary genre. Run chunked statics with reservoir sampling where needed. And finally, export visual and CSV summaries. The philosophy is minimal memory footprint, reproducible steps and outputs that plug smoothly into later section. Okay. And yeah, this is our this is my part key takeaways. Data is rating positive. Expect baselines larger than 3.0. Catalog is genre imbalanced, especially drama, comedy, heavy. Genre rating spread is real. Later models should control for it. Clean artifacts delivered for parts B to E. Yeah, that's all my part.
Yeah. We have 5 minutes, guys. See if you can squeeze up a little bit.
Yeah. Okay. That's to my teammate.
Yeah, hi, I'm Isaac. So I'll just brief through this part quickly. So this is the number of ratings per year. So you can see there's a few spikes from like 1995 towards 2005 is like fluctuating. And then from 2005 onwards is a downtrend for the number of ratings per year. Yeah, next. So average rating per year has been on a downtrend since 1995 to 2005. And from 2005 onwards, the average rating started to increase, but had a sudden drop in 2015. Next.
But again, this is because probably the data set is not complete. Right?
Yeah.
But I agree. Right. Go ahead.
Yep. Average rating against the release year has seen some spikes from pre-1900s to the 1920s, but it remained consistent till 2015 with a slight downtrend also because of incomplete data. And the top tags are sci-fi, based on the book, atmospheric, comedy, and action, indicating popularity of those movies that are related to these tags. And the prominent tags are like sci-fi based on book and atmospheric, suggest that audiences can probably engage more with themes and moods rather than just traditional genres. Next. And in terms of tags versus popularity, the scatter plot shows that movies with more ratings generally tend to have more tags, indicating a positive but weak relationship between the two. Most movies, in fact, cluster at the lower end with fewer than 10,000 ratings and 500 tags, while only a small number of blockbusters stand out as outliers, with extremely high engagement in both ratings and tags. However, the number of tags does not increase proportionally with ratings, suggesting that tagging behavior plateaus even as rating continues to rise. And the average rating by genre. The graph shows the average rating for different movie genres, with film noir having the highest average rating, and the lowest being horror. Yeah, next. And this is a violin plot. So this graph compares the distribution of ratings for multi-genre and single genre using violin plots. Yeah, so both categories show a similar range of ratings, roughly from 1 to 5, with medians around 3 to 4. So if you can see the violin plot, the median are the white, small rectangular boxes, while the interquartile range are the gray rectangular boxes, while the colored graphs are showing the density and the frequency of the data at several data points. Yep, next.
Here we see the distributions across decades. So the 1990s dominate with the highest number of ratings, followed by the 2000s. The ratings in the 2010s dropped sharply. This is mainly because our data set only runs until 2015, so the later decade is incomplete. More movies from the 1990s, 2000s, 2010s all average between 3.4.
Cannot hear you. Yeah, are you okay? Did you no? Yeah, cannot hear you. Oh, is it mine? No. Can you guys hear? Is it me?
Now.
Okay, now can.
Oh,
now
okay.
can hear you, yeah.
Okay, I'll just go to the last plot, the genre diversity. So here we examine how rating consistency changes with genre diversity. So for each user, we counted the number of unique genres they rated and compared it against their rating variance. So the scatter plot shows that users with very narrow or very broad genre preferences tend to have lower variance, while those in the middle range show higher inconsistency. This suggests that both niche specialists and very diverse viewers rate movies more consistently, whereas moderately diverse viewers are less predictable. Yeah. Next.
Oh, so you're training an autoencoder? Yeah. What is this? Guys, who's gonna tell me about this? Guys, who's gonna tell me about this? I need to know.
Oh, sorry, I think our group member is unresponsive, but he was in charge of this part.
No problem, no problem.
Yeah,
Because
sorry.
I can do it next time. I think we trained the model to do some predictions. So he'll tell us next time, yeah. Because we are running out of time, and I think everybody's tired after 3 hours of this. So let's continue next time. Group G. I already forgot about you guys, so my apologies. No, group H. Oh gosh, group H. So let's pick up next time, guys. No rush. Just in general, guys. So it was a very good day today. I think the spirit of the class is there. This is how I would like the classes to be. Just try to be a little bit quicker in your presentation, and try to diversify the presentation to what you expect other people to present, so that it's a little bit more dynamic. Everybody try to have everybody speak. So organize also the presentation so that you can switch quickly between speakers. And we'll release the new challenge on Friday. Please try to go through it. If you want me to, I will go through it next time altogether. No problem. Today I want to talk about model cross-validation and stuff like that, but no worries. I mean, it's for me, it's more important that you guys present your work than me present the slides that you guys can also read. Thank you to everybody. You did a great job. If you have any question or concern, let me know over Slack. Otherwise, Friday you submit the report with the video and so on and so forth. And then next week we move to the next challenge. If you have any questions, ask me now. If you want to leave, go ahead. Class is officially over. But of course, if you have some questions, I'm here. Okay. And I start the recording now. Ciao, guys. Stop the recording. Ciao to the people in the future. We'll see each other in the present at some point. Ciao.